all right, plus 1/2 through here, 1/3, x squared plus minus 1 to the 3/2 plus c. Wow. That's the antiderivative. Good choice, Chase. That one was a little bit different, wasn't it? It was almost like it was trying to trick you into picking the x cubed. Thinking that, okay, they're going to see the x squared and they're just going to go for it, right? Wow, can you believe that the derivative, if we took the derivative of that, what should we get? If we took the derivative, what should we get if we take derivative of that? X cubed, right? And then what? Square root of x squared minus 1. Do you believe that it is? Let's check it. We're going to actually do it. It's not actually going to be that bad. You ready? Here we go. I'm going to do these derivatives separately. Derivative of this, chain rule. 5/2 comes out. What happens when I hit this 5/2 with 1/5? It's going to be 1/2. This whole thing, I subtract 1 from that. What do you get when you subtract 1 from 5/2? 3/2. What's next?
Take the derivative of the inside.
Derivative of what's in here, which is 2x. Okay. Plus, now I'm moving on to this one. 3/2 comes out. 1/2. All of this time to the 1/2. And then times 2x. All right, the c's gone. Derivative of c is gone. Is that all right? Okay, so how about this 1/2 and this 2 go away? This 1/2 and this 2 go away. So I've got this. I've still got this x and I've got that, right? So this is going to be x squared minus 1 to the 3/2 plus, this one has an x also, right? X and then x squared minus 1 to the 1/2. Ooh. GCF, greatest common factor. Do you see a common factor in both of those? I agree. They both have an x, but they also have something else. They have an x squared minus 1 to the 1/2. So I can pull an x squared minus 1 to the 1/2 out. Understand that I'm pulling from this and this right here. What would be left if I pulled that out? So let's see. I pulled an x out, and I pulled this to the 1/2, which leaves me what?
That to the 1.
This to the 1. So you're basically subtracting a half from this, which would give you 3/2 minus a half is 1. So it's just this, right? That's left. And then plus, and when I pull this out of this, well, that is that, right? So I'm just going to have a 1 out here. The 1's cancel. And so this is just an x squared. And then you have an x. So it's x cubed. And then there's your thing to the 1/2. Isn't that awesome? I think that's pretty awesome. So it checks. All right, who's up next? Who's my next volunteer? Diego? All right, we'll go here. I'll come. I didn't see you. Diego, right?
Yeah.
All right, Diego. This would be pretty cool to play on your own, right? You meet up with a couple of your classmates, y'all go to the library, or you go meet at, I don't know, where do you meet nowadays? We used to do like gyms and stuff. We used to go to gyms back in the day. No, like gyms, like the food, like drink coffee all night. No, or the library, like we used to.
It's because they're open, they have free Wi-Fi.
Where?
James has free Wi-Fi and they're open.
Free Wi-Fi and they're open 24 hours a day. Yep. Okay. But wouldn't it be fun? You meet up with some classmates, you'll start taking turns doing problems. No? All right. Diego, you're up and you get to pick. So we just did number 20. 16. Oh my God. I've never seen a problem that bad before. No, it's fine. All right, Diego, here we go. This is number 16, off of some random worksheet that I found online. So Diego's playing right now. Root x plus 1?
Yeah.
All right, I'm going to put it here, and I'm going to take its derivative. Right? And you're telling me you see that somewhere? Yes?
Yeah.
Where is it?
It's the root x of the denominator.
Right here? This one?
You could just separate it.
1 over that. So we kind of did this when Daniel did this earlier, right? Same sort of thing. So pay attention to root x. Whenever you see root x's in integrals, always remember the derivative is 1 over root x. Well, 2, but if you ever see that, you kind of get the idea of what your substitution is going to be. So this one, let's see, 1 over, bless you, root x plus 1 squared, and then I'm peeling that off out here. I'm going to challenge myself in something I said earlier. Didn't I say the derivative of what you pick cannot be in the denominator? Do you all understand that this is not in the denominator?
Yeah.
That 1 over root x is an expression. Yes, it has a denominator, but the entire expression is in the numerator. It has a denominator, but it's not trapped underneath or like stuck inside of a parentheses.
It'd be different
Understand?
if you had something on top.
That's right. If I had something on top, that'd be a little bit of a different ball game. All right, so I'm going to replace this straight away with u, right? So this is going to become 1 over u squared. And then this I'm going to replace with what? 2 du. So we're going to have to, remember, we have to clear that 2 out again. So 2 du is 1 over root x dx. And now I can rewrite it. So I think at this point I'm going to rewrite this 1 over u squared du and the 2 out here. That's a 2. Yes? Yeah? And that, how would you find the antiderivative of this?
We get another power rule.
Power rule, right? You rewrite that as 2 integral u to the negative 2? And that's power rule. N is negative 2. So you just do your little power rule. 1 over n plus 1, u to the n plus 1. So I should get 2. It's going to come along. I should get 1 over what? 1 over negative 1, which is just negative 1. U to the negative 1, and then plus some constant. Almost there. Negative 2 over root x plus 1 plus c. So I just put the 2 and the negative 1 together, it gave me negative 2. And then u to the negative 1 really means drop the u down, doesn't it? Mm-hmm. This is really 1 over u. So I just put 1 over u here, but I replace my u with root x plus 1.
Wouldn't it be easier to leave it as x in the parentheses?
You could. It's not wrong. I
I just think it'd be easier because when you try to get a derivative of the elements,
if you had to do,
the proving.
if you had to somehow do something with that, again, we would probably want to keep this exponent like this. But a book is going to have that as the answer. Okay, my next one that I just thought of it, okay, I just said that would be a cool problem. All right, I think it's a little on the challenging side. So do I have a volunteer? You want to go with the challenging one? Okay, here we go. What was your name?
Albino?
Alonzo?
Yes, sir.
Okay. All right. Now this may not be hard. Just depends on you. Okay. Hold on, this needs to be to the fourth. I apologize. Albino? Albino? Okay, Albino's up. Let's see if he can get this. The most important step to a problem like this, and actually from this point forward, the most important step is to try something, all right? If you don't actually try something and you're just like, I don't know what to do, I'm going to go watch Netflix instead, then you won't ever get proficient at this stuff. So, albino? Hold on. This will make it a little bit easier. Take that out of there. Maybe that helps. Take the 4 out of there just so you don't have to worry about the 4. Kind of slide that over. All right. If you're stuck, if you are, I don't know if you are, go back, you're looking for something in its derivative. Do you see anything in its derivative there?
Yeah.
What do you see?
Yeah. So the derivative of arc sine.
Okay.
1 over x squared. Now you have the root of 1 over x to the power of 4, but if you were to take the power of 2 out of that, you'd have 1 minus x squared squared.
Mm-hmm.
And then that would still be in the root. I mean, the squared and the root would cancel, and then it'd just be the x over that.
Okay.
You have the derivative of that. The only thing would be that you have the x squared inside of the arc sine. So you'd have to take the derivative of that, and it would be 2x. And you have the x on top, you would just have the 2. Yeah, I think.
So what do you want?
You would be sine, arc sine of x squared.
Okay. There we go. Let's see. Let's see. Derivative of this. What is the derivative of arc sine of something? 1 over root of 1 minus whatever was in there squared. What's x squared squared? X to the 4th. Ah, okay. And then, you're not done. Times, that was just the derivative of arc sine of something. Now you have to take derivative of what's in here, which is 2x, right? Dx now. So you look at that big old clump and you say, do I have that? Absolutely, yes you do. It's right here. It's actually all this junk right here. All that right there, isn't it? But you're off by 2, aren't you? That's okay. You have a 2 here, you don't have a 2 there. I can get rid of this 2 real easy by just multiplying both sides by 1/2. Yeah? 1/2, and I'll even rewrite this as x over root 1 minus x to the 4th dx. So I just slid this x on top, just so it kind of looked a little more like what I see over there. Here we go. This should equal. Well, all this blue stuff is going to become what? All this stuff right here is going to become what? 1/2 du. And I still have down here this, right? But what is this?
1 over du.
That's u, right? So I'm going to have that on the bottom. So I have the 1/2 that came out. I still have the 1 over. This right here is u. And this whole blue stuff was the 1/2 du. So I slapped the du on the back. I pulled the 1/2 out. Albino, what's that?
You just have u to the -1.
Mm-hmm.
So u to the -1 plus 1. Oh wait, that would. That'd be that's natural log.
That's right. Okay, so this is the special case. This is u to the -1, isn't it? That's the special case. So we have 1/2 natural log absolute value of u plus c. And then replace u. So you should get a final answer, natural log of arc sine of x squared, close it off, absolute value plus c. That's it. Good job. Now what I was going to suggest, because I thought you were hung up, what I was going to suggest was, in a problem like this, if you can't see that entire thing happening, because you were seeing everything, like you could see the arc sine derivative in your head. Maybe you get something down, but I mean, you had it all going. If you can't see that all, then you still need to take a swing with something. So I would have suggested in this problem that I see x squared and I see its derivative off by constant. Right? Do y'all see that? So let's act like we didn't get it all in one shot. I could have said u is x squared, right? Then du would have been 2x dx. I have x dx, don't I? And so this would have become 1/2 du equals x dx, right? Just so I can make it match. And now let me rewrite the whole problem. Right? Let me rewrite the whole problem now.
Oh, so you're just going to do it in 2 steps?
I'm going to do it in 2 steps. So this is going to be integral, 1/2 is going to come out. I'm replacing the x dx right here, right? With 1/2 du, so there's the 1/2, here's the du. And then, let's see, since that x is gone, I'm just going to put a 1 up there. This is going to become square root of 1 minus, now what's x to the 4th? So go up here and look at this, right? You see that? If I square both sides, I get u squared as x to the 4th, don't I? So I can replace x squared with u squared. And then this piece right here is now arc sine of u. I've rewritten the problem. Do y'all see all that rewriting of it? Now I have to start over. Do I see something in its derivative? Yes. Arc sine of u. What's the derivative of arc sine of u? 1 over square root 1 minus u squared. So I would make a new substitution, and I wouldn't use u again. I would use a different letter. So maybe I'd say right now, v is equal to arc sine of u. dv is equal to 1 over square root of 1 minus u squared du. And then I'd rewrite this as what? 1/2 1 over u, 1 over v, right? 1 over v. And then this and this would be my dv. I'm going kind of quick and not very precise through this. I'm just showing you it can happen. This would be 1 over v dv. And then the antiderivative of that is natural log. So you would have 1/2